Okay, hello everyone. Okay, anyone still need the authorization code for the class? Anyone still need one? Okay, I think everyone already in the Moodle. Have you checked Moodle? The Moodle, you can log into the Moodle. Are you brother? Doing? Okay. I thought, like last class, I thought that I was confused. I saw the same person. Why they are look the same? Okay, you're doing something. Okay, nice to know. Okay. Okay. So our last note is on the increasing and decreasing function. So my plan for today is to, I think, hopefully we can finish off all these introduction about functions. And next week we can move to, and I hope maybe at the end of the class today, we can move to the introduction on limits and derivatives. Okay, so just to make sure that we are on the same definition, look on the screen. Okay, I have this two equations, seems two equations. Okay. F of x equal x squared minus x over x minus 1. And we have also g of x equal x. Question is just asking whether it is true that f is equal to g. Okay. Anyone agree that it's true? Is it true? True? You think it's true? Maybe? Okay.
It could be.
Okay.
It is
True? Why?
because when we change x squared minus x into
Okay.
x minus
Maybe, just maybe. Let me detach this for a while. Okay, perhaps you are thinking that this is we can let me do it right completely. This, right? Oh, we can cancel this? Oh, it's equal x. The same, right? Now this is a really good example to show you what is function. Okay, anyone who disagree? Think you disagree before? Why do you think it's not the same?
basically lost right now. I'm basically lost right now.
Okay. Anyone? You have to say something? Good. Okay. Very good. Okay. If it is not a function, if it is just an equation, just a normal equation without definition of function, this is the same. But we are talking about function. Okay? In function, f is not equal to g. Okay? Do you know why? The explanation goes back to domain. Okay, so the problem is on domain. For f, we should have the domain, right? What kind of domain that f has? Compared to g, we can input any numbers to g, right? No problem. 100, 1 million, we can put in G. But for f, remember that last time I talked with you about something like this, perhaps, that x cannot be 0, right? Or anything that is on the bottom here, that this denominator here should not be equal to 0, which means that in f, so for f,
let me write domain of f is x, or maybe just write x, as x is not equal to 1. While g, x all real number. Or you could write also the interval if you want.
Okay, so they have different domains, so they are different functions. Got it? Got it? Okay. And of course, you could actually try to visualize this using your graphing calculators, and you will see that on x equal 1, you will see some discontinuity, exactly 1 point. Because that 1 point making things undefined, right? Making things undefined, making things 1 over 0, okay? Okay, that's the, okay, so that's the function, okay, that's the function. Okay. So f is not equal g, okay? Okay, careful on that. Okay, now next, we can also describe from last class. Let me show you, we have 4 pictures, 15, 16, 17, 18, this is actually from the textbook. But what, between all these 4 pictures, which one is the function? You still remember how to distinguish function and not a function? Yes, take vertical line, the easiest way. So take vertical line, let me choose green here. Okay, we have a lot of points. Crossing 1, 2, 3, of course this is not a function, right? And for 16, I can cut everywhere and it is exactly 1 point. That's okay. Here also fine, right? And if you cut here, it's exactly also 1 point because it is open, right? Open interval. So it's also 1 point. Okay? But here, there is something interesting about this. Okay. Anyway, this is called a step function, but I think you will learn more in engineering of mathematics. But we don't really cover much about this. Okay. So we have 1, and I don't know how many points here, but it's more than 1, right? So this is no, no, yes, yes. But what's the context of yes and no? Yes means it is a function. No means not a function. Okay. Okay. Got it? Got it? Okay. Very simple, but sometimes you are too focused on formula calculation, you forget some important definition. Okay, that's a function. And we have more. Okay. Okay. I think. Okay, let's move on. Do you think you need to take notes here? I think this is just a review on how you using the vertical line, right? Okay. Okay, I will move now. Okay.
Now find the domain of the function. So let's try number 40 and 43. And I hope you can try the other as well after the class, if you want. Okay, and from this type of question, if you see the pattern, there are, I think, only several things that you need to remember. The first thing is rational. Okay? So if you have something like this that is on the denominator, okay, and then you have something in it like a square root, and you have something inside, right? And later, maybe not in here, you have also the log, right? Log something, because all these three usually they are a basic mathematical note that is restrict some numbers, right? Like for example, the irrational you need to have not equal 0. The square root you need to have greater equal 0. And here, what will be here? Should be what? Can logarithm be a negative number? No. Can it be 0? No? Yeah. So it should be positive, right? Okay. So only these three that is important, okay? So I mean, if it is important, then it perhaps will be asking in your test. So this will be, this should be not equal 0. This should be greater equal 0, and this should be greater 0, okay? Okay, now we can move to try 40 and 43. I think we cannot go for every number, but if we can, maybe later I will show you the other answer as well. So let's try number 40. Okay, we have x squared plus 1, a quadratic expression, and another quadratic expression on the bottom, x squared plus 4x minus 21. Okay. And of course, if you have a quadratic equations, your intuition will tell you to factor it, right? To factorize. Why you need to factorize? That's the question. Yes, we need to find, like I mentioned before, the functions will be defined by its domain, right? Because we want to know what kind of domain this function has, right? So how to find that domain is basically we need to make sure that we found which kind of x that when we plug in, it is not making undefined, right? So that's how we are going to take this and then just writing the factors. So x squared plus 4x minus 21 equals 0. So this will be what? 7, 3, right? 7 and 3. So it should be plus 7, right? Because it's plus 4, so it should be okay. Now we get that the one that makes 0 is x equal negative 7 and x equal 3. But it's not done yet. And I always suggest, because if you are in a situation where you are maybe in the middle of exam, I think 60% or maybe 70% or 80% you will be nervous. So to avoid mistakes, typo mistake or any miscalculation, what I suggest is always draw a number line like this. And then because it's not equal, so we are going to have an open interval here that is negative 7, and then here is 3. and then trying some numbers in between the interval, or maybe on those intervals. So maybe try -8, trying 0 is negative, right? And trying the above 3. Okay. But I think for this case, I think it's okay, right? I think all this will be okay, right? All this will be okay. So this will be okay, this will be okay. So you could just say that domain will be x, if you want to write the x is all real numbers, and x is not equal -7 and 3. You can write as simple as that, okay? Or you can write an interval. Yeah, actually you don't really need line number. Okay? The line number maybe if you have the square root. Okay? If you have square root, I think line number will be helpful, but if not, then I think you can step right over here. Okay? I think the line number will be helpful for number 43. I think if you write in the test, like maybe just directly x is not -7, x is not equal 3, it's also still okay. I will still correct it. So don't worry about the writing. But if you want to write completely, you can write like this or interval. Okay, try number 43. Number 43. Number 43. Maybe I will just erase the line number here and move this part, go here so we can have a more space. So hx is 1 over square root of with the power of 4 x squared minus 5x. I think still not too complicated functions, right? And for these roots, what you need to be aware is if you have the odd roots. The odd roots, it can be negative, right? Okay. But for the even, like 2, 4, 6, it cannot be negative. Right? Okay. Now, as I mentioned here, you need to have greater equal 0, which means, let me write here that x squared minus 5x, and since it is in the denominator, it's 1 over something, so I need to make sure that this is positive. Okay. So we can combine all those conditions. So we can combine the rational or with the roots and with the logarithm. Okay, we can combine all. And we can combine all together actually. But let's say we are going to just combining the rational and the roots. We need to have that equations, the inequality, which means we have, if we factor this out, this should be this way. And now the line number will be helpful. Okay? If you try out and then make the interval by yourself, I think you will maybe making some small mistake. So the zeros are 0 and 5, so we can take that, and it will be an open interval, 0 and 5. try in between, it's a negative. So negative is in between. And if you try negative number, it will be a positive, right? Negative, negative will be positive. If you have more than 5, 6, 7, and so on, it will be also positive. Okay? Okay. Okay, can you follow the idea?
Anyone still confused about how to get this positive, negative, positive? Okay, still okay, right? Okay. But in class, sometimes if you're missing out something like early, and then you try to force your mind to just survive in class, sometimes when you do that, you will lose something. You will lose focus. Okay? So if you have any trouble, I mean, if you lose something like maybe on the early classes, it's better to either asking your friend or asking me. If you're too shy to talk in class, you can ask your friend, maybe your friends know, or asking your TA if it's helpful. Okay? Or asking me after class. Okay? Okay? Okay, now back to here. We want the terms positive, right? So we want this interval. So we can say the domain will be n excluding the number and 5 like that. Or if you want to write using the inequality, that's also fine. You can write as well x is a real number and x should be less than 0 and x is greater than 5. Okay? Okay, if you still not get it, then perhaps if you take my basic math class, we are going to discuss a lot. Okay, okay, find the domain and sketch the graph of the function. I think this one we can skip for a while, okay? But if you want to sketch first, yes?
Why is it not x greater than 0?
Okay, good questions. Okay.
What happens if x greater than 0? Can you put here? You put 1. 1 minus 5, it's a negative. Okay. So that's why this line number is your tools to help. Okay. But if you are already familiar and you already know, sometimes you can skip this if you know your calculation. Okay. This is just to help. Okay. If you feel nervous, just to make sure to confirm your answer, just draw a line number and try the interval. Okay, because sometimes when you are having more complicated functions, it's not as simple as it is. Okay. This will be really helpful when we are in the chapter 4, when we try to sketch a graph using calculus. Okay. Yes?
Is it greater than or is it greater than?
Okay. Because we have the rational, we are not equaling this to 0, right? Okay. So it's like a combinations between the 1 over x and the square, the roots.
Okay. Well, I think I need to skip this one, but if you want to write the question first, you can write and then you can discuss it later if you have time. I need to skip this one first, okay? And then focus on the next part. Okay, you can take the picture if you want, take the photos. Or take the whole thing like with your smartphone. Okay. Now we move to. Oh, there's another one here. I will skip this one also. You can check this out. This is how to graph the piecewise defined function, which we described shortly last time. So every function is not always with one model. It can be with many models inside one function. And sometimes the function is not really continuous, so it will be having some discontinuity in between, in some intervals. Okay. This is just, I think it's supposed to be easy, right? Because it's not that complicated, each expression. Okay. Okay, I think we can skip it if you want to take photos as well. But I think, have I uploaded the notes? Not yet, right? Okay, after this, I will upload all of this. Okay, now we move to what we call the mathematical models. I think I will going a little bit fast here because this is just to describe some overview. So we have the very simple one, which is the linear model that you are familiar from early your education. So we can describe this usually by this expression, which m is for the slope or gradient. Okay. And this b is the y-intercept. Okay, very simple. And you can draw and prove this very quickly. Okay, that's linear models. And then another simple one is the polynomial. Usually we write in terms of this p of x. It means that it can be in any degree. Okay. Okay. I think polynomial, suppose you have learned in high school, I think. Okay. So the a is the coefficient. Okay, the a is the coefficient. And this let me write here nodes. Leading coefficient an should not be equal to 0. So we can take n for an integer if you would like. N equal 1, equal 2, and it will describe as linear, quadratic, cubic, and so on and so forth. I think that is the basic. Okay.
Which one will intersect? Which one? The y, this one?
Let me write a little bit clearly. Okay. I think we can move on. Okay, from polynomial. Oh, yes.
So I have a question.
Yes.
This one polynomial
Hmm?
the Lewis leading coefficient.
This one.
Lewis leading coefficient.
Notes.
Lewis.
Notes.
Oh, no.
sorry. Or maybe just write like that, okay? So this is called the decomposition. It's supposed to be not zero, and just to make sure that we have an ideal polynomial. Okay, go to the next one. So from polynomial, we could also have the form of the power function, which usually we just writing as simple as this x with power of a. I would like to distinguish between the polynomial and the power. So a is a constant. And of course, we could make a equal n, where n is a positive integer. Okay, this is going to be like this graph: x, x squared, x cubed, and so on. If you have the negative, then it will be different, right? It will be 1 over, right? 1 over x squared, 1 over x cubed, if it is a negative integer. Or we could also write as 1 over n, or let me write maybe here. And a can be 1 over n is positive integer. Maybe let me write around here. And this will be the roots, right? This will be f of x equal x with power of 1 over n, and this will be roots with power n, a root function. I think since it is introduction, I think you could just take notes that you think important, because I think most of the introduction is just reviewing your basic mathematics. Okay, this is to show you the difference between the even and odd. Okay. So this is even and odd in power function. Okay. I didn't show any roots, but I think we can draw something here. Let's say this is the f of x equals square root of x. And we could also see something like that. This is for the cubic roots. And notice that the cubic root has negative value. So it can be okay. Okay, let me add some notes here. If we have a equal -1, then it become reciprocal function, 1 over x. And when we have a equal -2, this is we call the inverse square law. I think the name not really meaningful for now. This is to show you 1 over x squared like that. Okay, since this is a reciprocal, we could describe the rational function. Okay, but if you want to take notes for now, rational function, just like we did before, like we have some expression defined by another expression, we call that a rational function. So why this basis disappear? Anyway. Okay. Rational function. This is f of x, and we have expression on the top and another expression on the bottom. Okay. And sometimes, because of this denominator, we could have some certain specific domains, right? That we need to exclude some numbers to make it defined. If not, then the whole thing becomes undefined. And usually, that number that is usually going to be make this undefined, we are going to have an asymptote. What is an asymptote? For example, just to show you the graphs, something like this. This is the graphs for, let me check what is the function. Function. Okay, this is for this function here. And you'll notice that if you factor, and you'll get this is 2 and -2. That number will be our asymptote here. Okay. But how to draw this is that will be in our chapter 4. And then the more complicated one, I think we call just a normal algebra function or algebraic function. We can go to the next one. But if you want to take notes here first, I will give you some minutes to do the note taking. Okay, for some parts in our introduction, I will just a little bit faster, okay, and then concentrate on the next part. Okay. Let me get going. So we have algebraic functions. This is simply construct construct from algebraic operation. Example, like a function. This is just an example. I'm writing a little bit long here. Okay, something like that, and we could just simply say this is algebraic function. Okay, and no need to write all of this. Okay, this is just an overview. I believe you already know. And then the next part is the trigonometric functions, like this one. Then the usual part will be the sine, cosine, and tangent. Okay, I hope you still remember how to draw this. at least remember some special value on the trigonometry, okay? Because we are going to involve, I think in most of cases, the trigonometry. Okay? And remember, we have
On the tangent, we have this so-called the asymptote, the thing that makes this function undefined if we make it into the function. Okay.
all right. We have the trigonometry, and then what else? We have the exponential and logarithmic functions. So exponent, like for example, we take this exponent, we call the one here the base, or in logarithmic, this is the base, okay? In exponent, this is the base, okay? Because they are related to each other. But I think I just show you just some overview. I'm not really going into deep. I will have this in another slides later. Okay, and then this is the complete descriptions. Okay, don't worry about the when you want to take photos. I will provide the file later on. Okay? I will upload the introductions. Okay, so just an overview. Okay, but I think I can go to the what we call is actually transformation. Okay, now this is important. So if you see
the black one here, the black curve. Is it too small? Is it too small? You can see, right? So you see the middle part here. That will be the original function. Okay? So what we are going to do here, we can transform this. The first one is just to translate. Okay? We have translation, which means we move this to the left, to the right, up, down. Okay? And then you see that when we go up, okay, we take the f of x and plus the constant. The constant will be the distance. And we take downside, we take minus. And then for the x part, you will notice that we're going to the right, y equal f, x minus c. Okay? And then y equal f of x plus c. So I think for up and down, if you just thinking about the numbers, okay, up means plus, down meaning minus. Okay, it's okay. But for right and left, we take x minus c to the right, x plus c to the left. Why? Why is that? Okay, remember what we are moving here is the value of f, which is y. Okay. But when we take here, it's the value of the variable, which is later you will see that will be the inverse of the y, which means that this should be minus, and this should be plus. The easiest way to try is just to take some random functions that easy to describe, like x squared or maybe just linear equations, and then try to do some trial and error by yourself to make sure that you understand that okay, this is x minus c and this is x plus c. Or if you happen to transform some functions, maybe going to the right or left, you can try and put some numbers, whether it is consistent or not. If it's not consistent, and then okay, maybe it's not correct. Maybe you are mistaken this left and right. Okay, I think that's the only logical way to prove or confirm. Okay. Okay. Another thing is on the right side here. You'll notice that the normal one is here, and we can multiply. We can multiply with some constant. Of course, if we multiply the f. Like for example, you have y equal x, just a linear one, right? You multiply by 2, which means your slope now is 2. It means that you can think the slope as the tangent, and the tangent in triangle. It is ratio between the one in the front and the one adjacent. Okay? So when you multiply by 2, which means that
it's going up more than it's going besides, right? Okay, I think it's easy to know this one. Okay, and then we have multiplied by 1 over c. Then if we multiply the x with half, okay, imagine, maybe let me just draw a little bit here. So if you take this as y equal x, and then we can multiply, so y equal x, this is y equal 2x, and this will be y equal half x. I think you can try that as well. I think it's easy to follow. And then we can have a mirror. Okay, we can have a mirror. If you multiply with a negative, like this one, -1, then you are going to reflect this curve with this x-axis, okay? And when you exchange x with negative x like this, it means you reflect, or you have a mirror with this y-axis. And again, how to make sure that we are correct? Just try some simple functions. The more you are getting used to doing that, try and error, the more you are getting used to the function itself. Okay? So this is just to show you at a later date, if you have like a function, for example, if I say the function as simple as, for example, x squared plus 4. If you are going to sketch this, now your perspective is, okay, this is just a regular x squared, and I will move it 4 points upwards. Okay? Okay. Okay, we take a break first, okay? Okay. Okay. So what we did here is just a simple transformations of the function. We shifted the functions, which we can shift vertically or horizontally, as you can see from my notes here, and we can stretch the curve as we multiply or we divide with some constant, okay? Or even we multiply with the negative or exchange the x with negative x, that will be reflecting the graph. Okay? But my suggestion is not to take all the notes here. As long as you understand what it is, it should still be okay. I'm afraid that you are thinking something and then you're writing the notes, and then you just write the notes and then what I'm writing. But for this one, the chapter 1, as long as you understand, this is because this is just review. Especially if you have learned before, just to make sure or maybe clarify or confirm that, okay, I understand that part, okay? Okay, this is the transformation, and another interesting one is the trigonometric. In trigonometry, we can multiply, and you can see that it's stretched to this number 2 from the cosine. Okay, but when we exchange the variable, we multiply with half with 2. We are going to see the stretch is going to be, or if you say. If you remember, maybe in physics, the periods will be different. And the periods. Okay. For here, if you remember in physics, the amplitude, right? The amplitude will be multiplied. Okay, just quick review. And this is an example. Okay, so if I have a square of x. For example, we expect that if we have square root of x minus 2, then we are going to, where we are going to move? Left?
Horizontally to the left.
Okay, careful. Square root of x is only x, which means that we move this to down. Okay, down how many? 2 points, 2 units. Okay? Take easy, right? Okay, what will happen if we have this? square root, but inside the square root we have x minus 2. We move to left or right. How many points? 2. So from here, so this will be our square of x. How about this? We multiply the square of x with negative. What kind of graph do we have? Is it moving or stretch or reflecting? Reflecting. Where? Here or to the left or to the bottom? To the downside, right? Okay. Okay, and this one is probably going to the left. And what's happened with this one? We stretch, right? We stretch. And it's going to be a little bit higher. So if we are taking this into, let me a little bit smaller. So going down, going to the right, and then reflecting bottom side, and then stretch upwards, and then reflecting to the left. Okay? Quick review. Okay. If you're still confused about this, there will be the complete manuals in basic math, but not in calculus. Okay? This is just a quick review. The next part, okay, you can. I think if you want to confirm your learning, just try by yourself square root of x, and then try all this, and then later you can check whether it's correct or not. Okay. Okay. Okay, we move now to the combinations. Okay. Now functions can be combined. Okay, we can plus, we can minus, we can multiply, we can define. Okay. And I think that's very basic. But I think the most interesting one is what we call the composite function, which defined as this. Okay. So we usually say FOG, okay, not the word fault, but FOG of x, which means that this function g is inside a function of x. So any function can be inside with another function, and it can be done many repeatedly, which means that you can have, for example, you can have f, but too many, maybe here, x, like that, or f, g, okay, this is just an example. Don't be intimidated. We can have many times. Okay? So not only just these two. And sometimes from one big functions, we can imagine what kind of smaller functions that will compose those big functions. Sometimes that might be helpful as well. Okay, so composite functions. Okay. Okay, if you want to write, you can write, especially the composite. Okay. Okay, now we have another one we call the exponential functions. Exponential functions, we state that f of x is equal some base with power of x. Okay. And if x is equal n and n is positive integer, and if x equals 0, then b with power of 0 will be 1. And if x equal negative 1, we are going to have b with power of negative n. Or it's negative n, sorry. And this will be 1 over b with power of with power of n. And we can also make x a rational number. X is so we can take p over q, which means that this is going to be p over q, or we can write into roots of q. Or we could write like that, okay? And if you see the graphs, the first one,
You see how the difference between the base and the graph. Okay. And interestingly, all the expressions of all the curve, they will crossing this point.
so this is, let me rename this. This is family functions y b with power of x. So you'll see
That when the base is getting larger, it's getting larger exponentially. It's getting increased really fast, going up. Compare with if you have the 0.5, it goes from here. So it's not like this, but it's going from there, right? Okay.
And to be precise, this is what I meant.
So when you have b power of x and the b is between 0 and 1, this is what you have. It's going to be decreasing like that. And when you have b is greater than 1, and this will be the graph you have. And if the b equal 1, then it means that it is just a straight line. Okay.
I think just a quick review, and the important, or
I think the unique on this exponent is, as you I think have learned, is the number e, right?
the Euler number. So you might know that E is approximately 2.71828 . It's an irrational number, and up until now, I think some mathematicians or scientists, they'll still figure out how many numbers behind the decimal. It's not complete yet until now. I think maybe for several hundreds, it's maybe not hundreds, maybe hundreds. But it's not yet complete. Like pi, like 3.14, you know that, right? But 14 something, it's really long. But what is E? What is E?
Natural law.
Yes, natural, not natural. Yeah, not natural. It's in the natural law. But what it is? Why it's called natural? Yeah, people call it natural. But why does they come up with the words natural to describe the E?
Golden ratio.
Yeah, it's related to golden ratio. So everything that has changes, and then it has, it can relate to the exponent, you will get the same ratio, which is this number. Okay? And I think in some way, before learning doing with the calculus, we can try to trial and error. Okay, trial and error. That's the best way if we don't know many things. Okay? Just try and error. So let's say we have this. Okay. Base of 2 and base of 3. And suppose that we have the slope for each one. When we have base equal to, the slope is 0.7. At this point, okay, at this point 0. That is what we are going to observe. Okay, and then we can make these two maybe 2.1, 2.2, 2.3, and then we can make a table, x and f of x. You could see that between 2 and 3, or maybe you could say 3, the slope getting 1.1. This number e is exactly when the slope is equal 1. That's one way you get e, one way. Try and error and see whether when you have maybe 2 point something, and you will find that, okay, we find the number 2.7 is getting close to 1. And then they try to find how to get more closer, maybe 2.78, and then another number as well. Okay, that's one way. Okay. So you could take the, so try y, b, x, and then try numbers between 2 and 3. Okay. And then this is what we have actually. If we want to describe in one picture, this is E, which is in between 2 and 3. So you will see that this e to the x is getting closer to 3, but not so much, which means that it's around maybe 2.7 something. Okay. Of course, to prove some of it, we need some calculus, but we are not yet there yet. So this is just to show you we could do it from trial and error. Okay. Okay. Okay, let me move to the inverse function. Okay. Like if you need more time to digest the first part, I will give in my basic of math. If you attend my class, I will give you, but I believe most of you already receiving all this information beforehand. Maybe not remember the things after we got here. So inverse functions. So what is inverse? So by words, inverse mean we are taking, so the simple word for inverse is exchange, domain, and range. Okay. And usually we have some symbols to denote the inverse, which is f and a negative 1, like that. And remember, this is happen a lot. Every year, I found out some students doing this. This is wrong, okay? Not reciprocal. This is inverse. It's different symbols. Okay. To know the inverse, or to have the inverse, or to make sure that the function have an inverse, one way to do it is to make sure the function is 1-to-1 function. Okay. So required for inverse. Okay. So what is one-to-one functions? A one-to-one function is every x will have every f of x, every y. And they don't have the same value twice. Okay? Which means that this is 1-to-1 and this is not. Because these 3 and 2, they have both the same y, or the same range, or the same f of x. Okay. So if we have, let's say we take the simple graph, maybe let me write clearly. Let's say we have the just a simple x squared. So is it one-to-one function? Is it one-to-one? No, right? Because if we have -2, we have 2, they both have 4, which means it's not one-to-one function. But the question, the next follow-up question is, does this function have an inverse? Can we have an inverse from this? You said it's not one-to-one, but can we have an inverse? I believe in my high school I solved some problem. I know it has inverse, right? The inverse is square root of x. Agree? Agree or not? Agree on square root of x. That is the inverse. But why we have this inverse from this? Okay, let's say we have square root of x, and that is you say that this is probably the inverse. Okay? If you remember, maybe your high school, I think this is one of the simple questions in your high school to take on the inverse. Okay, the inverse is this. But see, does it have another curve here? No, right? So what we can do to make this as inverse is domain. Okay, we restrict some domain, okay? And that's why we can have it. Okay, I hope you get it. Okay, I hope you get it. It's a little bit tricky because I'm going to have like a definition, but now I think it's very clear. This one is not one-to-one, but we can make it one-to-one. Okay, we erase the left part or we erase the right part, it's one-to-one, right? Okay? So if we erase this part, okay, now it's one-to-one function. Okay, okay, some notes here. Okay, it never takes the same value twice. That is the fx1 is not equal to fx2. Whenever x1 is not equal to x2. So how to make sure that we are having one-to-one functions? We are going to have a horizontal line. Okay. So let's say horizontal line here. It's exactly 1 point, which means it is one-to-one functions. Okay. How to check? How to check one-to-one? use horizontal line. Okay. Okay, this is so we have the cubic x cubes. So we take the horizontal line test, and it says that it is a 1-to-1 if and only if no horizontal line intersects more than once. So it's perfectly 1, 1, and every curve is 1, perfectly 1. And remember, if you have the even functions like x squared, of course, it will not be 1-to-1, unless maybe you pick out some domains, okay? Pick up some intervals, okay? Okay. I think the content now looks normal. I don't know why last time the screen was cut out on the left part. Maybe some technical issues. I think the same computer. I thought that there's just something wrong with the computer. So I'm giving like much space here because I'm afraid that it's cut out on the screen. Okay, any questions? Any questions? Now the technical parts is how to find the inverse. Okay? How to make sure that we got from x squared, we get the square root of x. Okay, now first let me get into the another definition. First, that is, if f is 1-to-1 function, and we say the domain A and range B. Okay? Now, the inverse, we can exchange the domain and range. So it has domain B and range A. And in other words, we could take that if we have, let me write from the right part first. F of x equal 1, and then we can take the f inverse y is equal to x. Okay? So domain of f inverse will be range of f. Domain of range, sorry. This will be domain of f. So if we take f of x equal x squared, we could imagine perhaps better write with y, so y equal x squared. So technically what we can do from this, if you want to find the inverse, is we solve x, okay, we solve x, that is y, 1/2. And then exchange y with x. So x become f inverse x, and this will be x. Okay. And then you can also write, if we have f of x is x squared, and then f inverse is x with power of half, then f inverse y is f inverse x squared half, which means we can see that this gives you back the x. And then this is true also. So let me write again. So f inverse x is equal y. Fy is equal x. Same thing, okay? We can exchange both of them. And if we take f inverse of f of x, So the f of x we inverse. The result will be x, as we mentioned here. Okay. And then we take f inverse x. This is also for x. This is true for every x in A. This is for every x in B, refers to the previous parts. So what we are doing here is actually, let me just give you a description here. So we start by x. We start by x. We take x, we put into some machine we called f. And we get the result that is f of x, right? And then we take the f of x, we take into the machine called the inverse. What's happened is we get x again. So which means that this f inverse undoing the functions. Okay. Okay, I'm adjusting this size and the place so we can have a little bit space down there. Okay. Okay, so let me write one by one the steps how we can technically find the inverse. If you think the previous one is not clear enough. So for example, if you want to find inverse of function x cubed plus 2, okay, I'm still using simple equations like this. So the idea here is we are going to write, let's change f of x with y. I think it's easier to follow if you want to calculate. Okay. And then we are going to solve x. Okay, so x cubed, let me write one by one, will be y minus 2. Okay. And then solve x become square or a cube root y minus 2. And then the last part, we're going to interchange x and y. Okay. I believe most of you are able to do this, right? But the reason why we change x, y is because of we exchange the domain and range. Okay. Now we get our inverse. Okay, I will move for a while to another computer. Okay, now this is the same functions as we written to find the inverse. I have the x cubed plus 2 and cubic root x minus 2. And then we can see the curve. You see the similarity? It's like they are mirroring each other. Right? And how they are mirror is actually because of the y equal x. Okay, so you could also consider an inverse from a graph. So you can reflect the graph with this line. Okay, let's go back to our notes. So that's why we could take this. Okay, so they are perfectly mirroring using the y equal x. So we can say the graph f inverse is obtained by reflecting f about line y equal x. Okay. Any questions? Any questions? Okay, any questions? Okay, we have a little bit small section, but I think I will complete that sections next week. And then we can move to limit at the very first chapter for calculus. This is, I think, I believe functions is like a pre-calculus stuff. If you want to know more completely about functions, I think I will also cover in basic of math. Okay. Okay, any questions? No? Then I will ask. Do you still taking the notes? No? Okay, now you are unsure about your future. Can I pass this course? But like this is a fundamental courses. Like it's like 4 credits because in most engineering courses, like mathematics is a tool to understand the problems or to translate the problems to solutions, right? So if we don't understand the fundamental part, you will be having difficult times in the future. Okay? So it's like better to like understand first and maybe having not really good score, compare with if you are just okay, maybe just barely pass and then. But if you're doing that, I'm not sure what will happen in the future. Okay. So let me doing some not comprehensive, just a few tasks. Okay. Okay, so you can use a website, joinmyquiz.com. And you can take this code and enter the code. I think the time should be taking no more than 5 or 6 minutes. Maybe 5 minutes. 5 minutes. Less than that. Is it okay? Or not? And my suggestions is to use your real student ID. You can redo if you want. You can redo if you want.
It's already too late.
Okay, use your student ID. That will be very will be okay if you're using student ID. But in case you get some good score and you are not using your student ID, let me know which one of you. Okay, everyone already joined? I'm suggesting you to join, but if you think you don't need, I appreciate your decision. Still okay for me. But you'll get 0. That's okay. I mean, it's not like only small percentage. Like if you feel really tired, it's okay. Okay, I think already all right. Already right? Okay. I think we can go to the next question. Okay, next question. I haven't yet emphasis on it, but I hope you get the idea. Yeah, I will try to explain more about it, but I hope you get the conclusion from what we have talked before. Can we? If you're curious, you can imagine any number and you can put it into the expression. Okay, let's stop. Okay. 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 Good. Good. Okay. Which one of the following in some way, questions like this motivates you like to learn again. Like I'm just preparing a simple question just to make sure that you understand like the fundamentals. Remember odd and even. We can check my something with something. Raise hands. Raise hands means that you want to know the answer. Oh, this is raise hand. And sometimes there will be a function that is not even, not odd. It means that it is outside of even and odd. Question is asking which one is odd. Okay, speaker, no time. I forgot how many questions I think we still have one more, I think. Okay, so x cubed minus x to the power of 7. That will be the answer. Okay, fine. No, this is, I think, last question. The fourth question. Okay, I'm giving you the simple one. Square root 16 minus x to the power of 4. Compared to like finding which one is the right answer, it is more difficult to create the question itself. So the timer means that it is expected that you are going to solve this kind of question within that time. It is too short or maybe too long. Let me go. Just raising hands. You like this type of like postcard? Sometimes in a while. Just to check whether you are sleeping or not. Okay, 4, 3, 2, 1. I think these two are wrong name, right? Okay, that we have the winner. GDAP student 006. Which one? Can I know which one? 006 GDAP, I think. Okay. Okay, I think that's all, and I will consider this quiz also as an attendance. So see you next week.
What if I wrote my name differently?
What's it? What's it?
I wrote Vietnam.
Okay.